Good day, pre-algebra. We are going over our first PO of the year, which is greatest common factor. Again, review from last year, but we are going to get into some more real-world word problem situations when you would actually use this concept. The definition for today, factor. What is a factor? A factor. Okay, well, I'm going to assume we're all going to learn something new today then. A factor is a number that goes into another number evenly. A factor is a number that goes into another number evenly. Okay, for example, what are the factors of 12? What are the factors of 12? Yeah. 6 goes into 12 evenly. How many times does 6 go into 12 evenly? 2, right? So 6 and 2, they would be considered like a factor pair. Okay, it's the pair of numbers that together can make 12. Yeah. 4, and what does 4 buddy with? What's 4's buddy? 3, right? 4 times 3, or 3 times 4, that's a factor pair of 12. And what is the third and final factor pair of 12? Yes. 12 goes with 1, right? Okay. 1 is a factor of every number because 1 goes into everything. And then we also have a couple other factor pairs here. Yeah.
Could there be like negative 12 and negative 1?
So negative 12 times negative 1 does give us 12. However, the context which factors are used is like an area, you know. So 6 and 2, that's a factor pair because you can make a rectangle with an area of 12 that would have values of 2 and 6, right? Because to find the area, you take the base times the height. 6 times 2 gives us 12. You can't have a rectangle with an area of 12 with values of negative 6 and negative 2, or negative 12 and negative 1, because what did we just learn about distance in CO3? Distance cannot be, starts with an N, it ends in negative. Good job, so proud of you. Yeah, you can't have a rectangle with sides of negative values because that's not a measurement, right? So to say that negative 12 and negative 1 are factors of 12, yes, but no. Okay, you would never really write them down as factors because contextually they don't really fit. But good question though, very good question. Any other ones? Questions? No. Okay. So finding the greatest common factor of two numbers. Method 1. I'm going to teach you 2 of them. Method 1 is called the listing method, and this is probably how you first learned to find greatest common factor, because all you really do is you list them out, or as I say, it's easy as 1, 2, 3, or FCG. What does the F stand for in greatest common factor? Factor, right? Your first step is to list the factors of each number. Okay? List the factors of each number, like we did with 12 up there. We listed the factors, 6 and 2, 4 and 3, 12 and 1, right? C stands for, Tristan, common. Okay? So then you want to identify the common factors. Identify the common factors, right? What factors do both numbers share? And then the G, mirror on the wall, which is greatest of them all? The greatest of the common factors, greatest common factor, is the answer. Okay? And again, this is probably how you first learned it, which is why knowing your multiplication tables is such a big part of this listing method. If you are someone who have your multiplication tables memorized, you kind of just have good number sense, you know what numbers go into other ones, you might prefer this, okay? If you don't, then we've got another method called the table method, which you should have been shown last year also, but we'll cover it again here, and we'll get to that in a little bit, okay? But questions so far? Everyone caught up on the notes? No? Okay. Give you another minute. Okay. Start with 40 and 72 there. Well, we'll wait for folks to catch up. The first one, well, there, 40 and 72. Use the listing method. List the factors of 40 and list the factors of 72. And then we will we'll get caught up together once notes are jotted down. Okay, so just make a column for 40, list the factors, make a column for 72, list those factors there. And if you still need the notes, you can catch this video on YouTube. Don't forget to like and subscribe. Okay, 40 and 72. Let's start our list here. What factors of 40 and what factors of 72 did you come up with? Give me in factor pairs, please. Yeah, Zoe, give me one factor pair. Okay, so we have 8 and 5. One factor pair. Nolan? 2 and 20. 4 and 10.
40 and 4.
Yeah, someone's got to say it. 40 and 1. Any others? Okay, and this is why I said earlier, knowing your multiplication tables is really important for the listing method, because how do you know when you're done, right? We have 4 factor pairs. How do we know that that's all of them, right? Well, if you're comfortable with your table, you know that's all of them, right? But if you aren't, then you might be questioning that. So one downside, one con of the listing method. 72, what do you got? Yeah. 9 and 8 make 72. They're both factors. What else? 72 and 1. Get it up there. Someone has to say it. 72 is even, so you know that 2 goes into it. How many times does 2 go into 72? Half of 72? Close. That'd be 70. So 1 more 2. 36. 2 and 36. Okay. Now, those that spend time with me over the summer, we play what's called the flip card game. And one of the things I have you do is practice factors. And so one trick that I always talk about that some of you might remember here, once you get one factor pair, you can find others by taking half of one and doubling the other. Half of one, doubling the other. So if we take half of 36, what do we get? Half of 36. 18. If we double 2, what do we get? Double means to multiply by 2? 4. 4 and 18 is another factor pair. Isn't that nifty? We took half of one factor, doubled the other, we can get another factor pair. If we do that again, take half of 18, we get 9. Double the 4, we get 8. Well, we already have that one, right? That's how you'd find another one. It also works with other numbers other than just having and doubling. Let's take 9 and 8. Okay, what can we divide 9 by? Tristan? 3. If we divide 9 by 3, we get 3. If we triple 8 or multiply 8 by 3, what do we get? 24. Another factor pair. Ta-da! Math's so fun. Okay, so that might be something that you can use if you're unsure. Just kind of play with the factor pairs you have, right? See if you can come up with others. How can we get another factor pair from 3 and 24? Take half of one and double the other. What do you get? Can't take half of 3, so take half of 24. Yeah? Excellent job. 6 and 12. Okay? 72's got a lot of them. 72 is a big factor number. Okay, but I believe that's it. So we've listed the factors. Now we look for the common ones. What are some common factors? I see that 1 appears in each of them, and they both have a 2, and they both have a 4, they both have an 8. Think that's all. So, mirror, mirror on the wall, which is greatest of them all? What's the biggest number of 1? Thank you. 8. And so the GCF would be 8. The greatest of their common factors is 8. Okay. Now, if you are not a, like I said, if you're not a listing person, if this is challenging because how do you know when you're done? How do I know I have all the factors? If you missed 8 and 5 going into 40, you wouldn't have gotten the right answer because you wouldn't have had it, right? So the table method is another way to do this that just kind of keeps it a bit more organized. And it looks like this. Like I said, some of you might remember this from last year. We're going to make it like this. Does that look kind of familiar? No? Well, good. Then you learned something new today. Okay? And what we're going to do is we're going to put a 40 and our 72 in these top boxes here, the middle box and the right box. And all we have to ask ourselves is, what's the number that goes into both of them? It doesn't have to be the biggest. Just what goes into both 40 and 72? Okay, let's not start with 8. I'm going to show you how this works. Yeah. Well, you can't use 1 because of what we'd have to do next. Yeah, because another one. Okay, 2. So we know that 2 goes into both 40 and 72. Okay, so the 2 goes in that far left box there. And then what we're going to do is we're going to divide 40 and 72 by that number. That's why we can't use 1, because 40 divided by 1, still 40, right? And what is 40 divided by 2? Good. Everyone said 20. Excellent. And what is 72 divided by 2? Everybody? 36. Okay? And now we ask ourselves the same question. What goes into both 20 and 36? Yeah. 2 does again. You could also use 4. This time I would allow 4, but we'll use 2. Okay? So 2 goes into both of them again. And so just like we did in the first step, we're going to divide 20 by 2 and divide 36 by 2. And 20 divided by 2 is, everybody? 10. 36 divided by 2, everybody? 18. And we ask ourselves the same question again. What goes into both 10 and 18? 2 does again. So we're going to put our 2 over here. And once again, we are going to divide by 2. 10 divided by 2 is 5. 18 divided by 2 is 9. And is there a number that goes into both 5 and 9? Other than 1? No. So that's how we know we're done. Okay? So just see the difference in the processes here. This one, you have to know all the factor pairs. This one, you just have to kind of take it step by step. Just pick a number that goes into each of them and work your way down until there aren't any more common factors. And how do we get 8 as an answer here? Because we know the answer is 8. I don't see an 8 really anywhere up here. How do we get the answer? Sorry? Well, how we get the 8 kind of is we're going to take these 2's that we have over here, and we're going to multiply them all together. 2 times 2 times 2 equals 8. Okay, and that's why I didn't let Anthony pick 8 the first time, because it would have gotten us straight to the answer, right? If we had picked 4 here instead of 2, giving us a 2 and a 4, 20 divided by 4 is 5. 36 divided by 4 is 9. So we still would have gotten down to 5 and 9, and then 2 times 4 would have gotten us 8 also. So it doesn't matter what number you start with or how many numbers it takes to get down here. Eventually you do, then you know you're done. Okay, do you remember this from last year? Does this ring a bell? Some people are saying yes, some people saying no. Okay, well, here it is, not for everybody. Bless you. Okay, questions so far? All right, we're going to skip the next one and go to the second page and pick another 2-digit. Let's do 24 and 84. We'll do both methods again, just so you can really get a chance at each of them, and you kind of get to pick a favorite and roll with that one. So starting with 24 and 84, we'll use the listing method. Give me some factor pairs of 24 and some factor pairs of 84. Maya. 4 and 6 make 24. 12 and 2 make 24. Thank you. 24 and 1 make 24.
I just realized it's already up there. 8 and 3.
8 and 3 make 24. Is that all of them? That's all. But let's go to 84. What makes 84?
42 and 2.
Okay, 42 and 2. I want to write these a little bit smaller because this one's got a few. Should we use our trick? Use our trick. What's half of 42? Half of 42. 21. Now we double the 2. Since we divided by 2, we're now going to multiply by 2 and we get 4. Huh? That's fun. We can't take half of 21, but what can we divide 21 by? 3. What's 21 divided by 3? 7. And now we're going to multiply 4 by 3. What do we get? 12. 7 and 12 also makes 84. Ooh. How can we use 7 and 12 to get another factor pair?
So you make the 7 and 14, and then you divide 2 plus 12.
Double the 7, take half of 12. We get 14 and 6. Anyone see any others? Zoe? Sorry? And if we didn't already have 7 and 12, that would bring us there, but we already have that one, so we don't need to write it again. So instead of taking half of 14, why don't we take half of 6? Aiden? Or do you have another one? Yeah. Yep. Got to put it up there. Okay. But back to that 14 and 6, half of 14, we already got the 7, but half of 6, double 14?
Yeah. Half of 6 is double 14.
What is that?
28.
Yes, 28 and 3. Any others? Got 1, 2, 3, 4 is up there, 5, 6, 7, 8. I think that's all of them. Okay, quite a list. All right. But again, a number like 84, I mean, who knows off the top of their head that 28 and 3 makes 84? I don't, right? You have to work your way to get there. Again, if you know your multiplication tables well, it doesn't take long, especially if you have that neat little trick, but it's still easy to miss. But let's look at our common factors now. We've got common factors with 4 and 6 and 12 and 2 and 1 and 8. Nope, not 8. My bad. And 3. Mirror, mirror on the wall. What's the greatest of them all? 12. And that's the greatest common factor. Oofta. The listing method. Let's go to the table. 24 and 84 go in the middle and right boxes there. And not 12, but what's a number that we know goes into both 24 and 84? Nolan? 2 does, right? If they're both even, you might as well start with 2, because that will at least cut them both in half. Okay, if both the numbers are even, start with 2, unless you can think of something larger off the top of your head. So a 2 goes in each of them. 24 divided by 2 is 12. 84 divided by 2 is 42. And now maybe we're in a little more manageable situation here. What's a number that you recognize goes into both 12 and 42? Tristan? 2 goes in both of them. Let's not use 2 again, so we use 2 3 times in a row on the last one. Tristan, what's another number that you know goes into both 12 and 42? Landon, hello? 4 does. Okay? Not go into 42. 4 goes into 40. 4 goes into 44, but not 42. Skips over it. Does personal space mean anything to you? Penelope. 6 does. Okay? You might recognize 6 goes into 12 and 42. And so when we divide 12 by 6 and divide 42 by 6, that gives us 2 and 7. And how do we know we've reached the end of the table? What? Sorry? Well, because we know the answer is 12, right? But if we didn't know the answer was 12, how do we know that we can't go any further with our table? Right. Yes. Right. So both 2 and 7 are prime, but there's no number that goes into each of them. Okay. So we are done here. We look at our numbers on the left. We multiply them together. And 2 times 6 equals 12. Okay. Same answer as we got with the listing method. Just by a quick show of hands, who prefers the listing method? Who prefers the table method? Who wishes I didn't teach greatest common factor? Oh, less than usual. Well, that's a good sign. Okay, all right. Who's tired of my polls? That's fair. Okay, that's fair. So here's what I want you to do for tomorrow. Pick one of these methods, pick a favorite, and just do 18 and 42 and 45 and 150. Just those 2 for tomorrow. Folks, I'm giving you major opportunity for the number game here. 2 homework questions. Okay? All I'm asking for tomorrow are these 2 questions. But please don't forget to show your work. If you do not have work shown, you will not get credit. I need to see the listing method, the table method, or if you have an alternate method that you're like, my dad showed me this and I love it. Great, but show me how you got there. Okay? No. I want to see the work. Whatever work you do, show me on the page. You can switch off. You can pick just one of them, do the same one both times. You can alternate. Show me the work. Those 2. Those 2. Yes, Ryan? No, there's only extra credit available on tests, not on homework. Okay. All right. Questions, comments, concerns, complaints, compliments, congratulations, criticisms. Okay. Folks, I believe in you. You can do this. That's how you math. Don't forget